Whoa, class, that was a little crazy, right? We're going to keep on rolling here. Part 2 of implicit differentiation. All right, dy, let's find dy dx for this particular function right there. Now, this looks a little nutty, but let's go back to chain rule stuff, right, class? We have an inside, we have an outside. The inside is x plus y, the outside is tangent. Let's take the derivative of tangent. Derivative of tangent, hopefully you know by now off the top of your head, that would be secant squared. Don't you dare touch that inside. But guess what? I have to multiply it by the derivative of the inside. And the derivative of x plus y would be 1 dx over dx plus the derivative of y would be 1 dy dx, right, class? And that would be equal to the derivative of x, which would be 1 dx dx. Okay, now this one's pretty tough because a lot of you will make a little bit of a mistake here, and there's several ways you could finish this. For one, I could distribute that, but I think this one is a little bit easier if we just divide that secant squared on both sides. Check that out. That's legit. There's no magic going on there. And then subtract the 1. So I get an answer of dy dx, which is equal to 1 over secant squared. Well, that dude has a cousin, right? That's actually cosine squared of x plus y, and then minus 1, because we're going to subtract that 1 over. Okay? So not too bad, right, class? But there are a lot of mistakes usually happen as we move forward with a problem like that. All right, example 5. Now, this is where we kind of really get into the gist of calculus. We're in the real world, right? We have all these crazy shapes. We have satellites that go in these crazy directions and paths. And we have this beautiful picture right here, which is being represented by that equation, right? That would be implicitly, right, class? Because we have the x's and the y's. And, you know, this is a prime example of why implicit is so important. Try to get y by itself in that bad boy and show me that tomorrow. I'll give you some candy if you can do that. Okay, that's going to take some time. So instead what we do is we solve for dy dx implicitly. All right, so let's go ahead and do that. The derivative of x cubed, 3x squared, dx dx. The derivative of y cubed would be 3y squared, dy dx, right? Because we're always taking the derivative with respect to x. Okay, believe it or not, what would it be if it was dx over dy, right? It just kind of would be the flip of everything. Okay, and then on this other side, we have to take the derivative of 6xy. Okay, so I'm going to treat that as 6x being my u and y being my v. Okay, so that's a little bit of a product rule, right, class? Oh, snap, what happened? Don't go away. Good stuff. All right, so the derivative of let's write 6x times the derivative of y, which would be 1 dy dx, plus the derivative of 6x, which would be 6 times y. Okay, and that's it. Now, this is a prime example of where we went through those guidelines, right, of doing all these. Is first we go ahead and we take that derivative implicitly, and then we get all of the dy dx's on the left-hand side. So I'm going to do this. We would subtract that 6x, and we're going to move everything else on the other side, which would take that 3x squared and put it over on this side. And then what we're going to do is going back to our algebra 2 skills, we're going to factor out a dy dx. Right, not too bad. Hopefully you're able to finish this bad boy on your own. And then we're going to just divide out. Okay, and we get kind of a final answer here for my derivative, dy dx, equal to 6y minus 3x squared all over 3y squared minus 6x. Now, you're able to do this as long as you're very careful and you're 100% positive that it works out, okay, class? And that is that I could take a 3 out of everything, okay? And we get 2y minus x squared over y squared minus 2x. And when I simplify like that, it can make a lot of the work later on a little bit easier to deal with, okay? For example, it says find the equation of the, circle that bad boy 3 or 4 times, of the normal line at the point 4/3, 8/3. So the nice thing here is my very first step is I should write out the equation in point slope form. It'd be y minus 8/3 equals m times the quantity x minus 4/3, okay? And then all I have to do here is find the m, right? But I'm going to find the m. This is the tangent right here. So you could do a little opposite reciprocal of that, but I think you might be causing yourself a little bit of a headache. So I'm just going to get down in my little stance here, okay, once I get rid of that stuff. And let's go ahead and find dy dx. Remember, the correct notation is that bar right there. And we're going to plug a 4/3 in for x and an 8/3 and for y. Let's do that math. Let's see what we get. We get -2. Plug my y in there. I get 8/3 minus 4/3, and we're going to square that bad boy all over y squared. So that'd be 8/3 squared minus 2 times 4/3. Do some math. 16/3 minus 16/9. All over, what would that be? 64/9 minus 8/3. Oh my gosh, they all have a 9 in it. So let's just multiply the top and the bottom by 9, and we get 48 minus 16 over 64 minus 24. What's that give me? That gives me a little 32/40. Oh, snap, class. That reduces, doesn't it? 32/40. Oh, they both have an 8 in that bad boy. That's 4/5. But I have to be very careful, and I have to remember that is the slope of the tangent line. Normal, opposite, reciprocal. -5, force booyah. Problem done. That's kind of a tough one too, right? So hopefully not too bad. But let's keep on rolling. Cool thing about this one, actual old AP question. Challenge yourself right now. Hit pause and see how you do. Actual old AP, we practice this stuff later, but it's 2004. Hopefully you practiced it. Let's see if we can show that we get that as an answer. To check that out, we take that derivative implicitly. The derivative of x squared is 2x plus the derivative of 4y squared would be 8y dy dx. Apologize for the writing. Equals the derivative of 7. Biggest mistake here is people keep that 7 in the problem. The derivative of the constant is 0. Okay, but then we have a little bit of a product rule there. Okay, be 3x times the derivative of y, which would be 1 dy dx. Apologize for the handwriting. Plus the derivative of 3x, which would be 3 times y. Okay, what was our rule? Get all of the dy dx's on one side. Right, we subtract that. And then get all of the x's and y's on the other side. And it doesn't matter what order you put those bad boys in. Right, what was the next step? We go ahead and we factor out a dy dx. And then we divide. And let's see if it matches up. Then I don't have to stress out on the AP exam. If it doesn't match out, I'm probably going to be stressing out. Oh, snap. I got that piece right. But that might mean the next piece might be a little bit tougher. Let's go ahead and see what the next piece asks. Show that there is a point P with x coordinate 3 at which the line tangent to the curve P is horizontal. Find the y coordinate of. So what we want to think about right now is what does it mean for a tangent line to be horizontal, right? Going back to the beginning of this chapter, and even last chapter, that means we want a slope of 0. Well, we want a tangent line slope of 0. Well, that means we want our dy dx to equal 0, and our dy dx, right, was 3y minus 2x over 8y minus 3x. Now, I hope we all remember that a fraction is going to be 0 whenever the numerator is equal to 0, right, class? So what we really want to do is we want to know when 3 minus 2x is equal to 0. And guess what? The AP helped me out a little bit. They told me that the x coordinate, when we had a tangent line horizontal, was equal to 3. So guess what? I could put a 3 in for x. And if I do that, I get a little booyah, right, class? Let's solve that guy, and then I'm going to get the y coordinate, right? Let's go and solve that. And so we get 3y minus 6 is equal to 0, which would be y is equal to 2. Everyone with me? So we got the y coordinate, and that's what they asked me to do here. Let's go ahead and see what they ask us to do in the next step. They actually say find, ooh, fun. They asked me to find the second derivative. Oh, sweet. You know why? Because I get to do a little bit of quotient rule, right, class? I mean, how fun is that? So let's go ahead and find the second derivative, and it says to find it at the point P found in part B. And our point P would be, what would it be? It was 3, because that was the x coordinate, comma 2. Okay, so we're going to have to use that in this piece. But I get to do a lot of the fun first, right, class? Let's find the second derivative. Okay, a little notation of second derivative. Low, d high. The low, and the low was 8y minus 3x, right, class? Times the derivative of the high, and the derivative of the high, oh, snap. That's a little bit of a implicit differentiation I have to do up there. So it'll be 3 dy dx, right, class? Minus the derivative of 2x, which is 2, minus the high, and the high is 3y minus 2x times the derivative of the low. And when I take the derivative of the low, it's going to be implicitly also, so it's going to be 8 dy dx, apologize for that writing, minus 3 all over, no. Right, so that'd be 8y minus 3x, and I'm going to square that bad boy. Okay, whew. Plug and chug. Right, class? We got to plug and chug some stuff here. But I'm gonna use kind of my brains here, okay? And if we go back to part B, let's make this bad boy blue, right? We found dy dx at the point 3, 2. And if we recall, at the point 3, 2, we had a horizontal tangent. And so if I plugged a 3 over 2 into that derivative right there, guess what I am going to get as an answer? I'm going to get 0. So guess what that means, class? Whenever I see a dy dx, I'm going to get an answer of 0, right? Dy dx, I'm going to get an answer of 0. So I guess in my next step, shame on me because they wouldn't technically be equal to each other. I'll do this in blue, okay, class? Is I'm going to take the second derivative, but it said after I find the second derivative, I'm going to find it at the point that we found in B, which is 3, 2. Okay, and then I can do those little 0 and 0. And then all I have to do to finish this bad boy out is it would be 8 times my y, which would be 2, minus 3 times my x, which would be 3. Okay, and that's that first piece, correct, class? And then I'm going to multiply that by negative 2 because I'll still have that negative 2 from that piece right there. Minus, let's go 3 times the y, which was 2, minus 2 times the x, which is at 3. And then I'm going to multiply that by that negative 3 all over low, which would be 2 minus 3 times 3. Booyah. Oh my gosh, that's some crazy work. And I'm not doing it all. You're an AP Calc. So if you want to check your answer, I think I get a final answer here of negative 2/7. And if you're able to do all that stuff, you are going to be money on that AP exam. If you look at what's at the bottom of the screen, it's 3/8. So we are done. That's part 2. See you in class. Do your worksheets.